In this video, we'll talk about C# delegates and anonymous functions, which are things we'll encounter quite often later on. We'll start with something we are familiar with, object reference. In an object-oriented language, we see an object variable is a reference because it points to an object rather than holding the object. For example, if we assign a string hello to the variable x, x simply points to the hello object in memory. If later we assign abc to x, x then points to abc instead, and the hello object is still there, not being overridden. Since we have object reference, naturally we would wonder if we can have function reference. A function reference would point to a function. For example, if we assign function a to x, x would be pointing to func a, and calling x with 10 and 20 would produce 30. Later, we can assign function b to x. Then calling x with 10 and 20 would produce minus 10. It will be just like object references. At this point, you may be wondering why. Why do we want function references? Well, the need is surprisingly common. For example, in event-driven programming, like programming GUI components or Ajax web programming, we often need to call a function when something happens. For example, a button would have some text, some width and height, but it also needs a click event handler, which is essentially a function to be called when someone clicks a button. Here, it would be nice to make click a function reference, and the user can then provide a function and assign it to click. In fact, most languages have function references or something similar to it. Many of you know JavaScript. In JavaScript, functions are in fact objects. So function references are really no different from regular object references. In C, there's something called function pointers, and in Java, there's no function reference, but Java has kind of a workaround. Instead of functions, it uses objects that implement certain interfaces, so it's guaranteed that these objects have certain methods. This is what a function pointer in C looks like. We can define a function, for example, add1 here. We can then take the address of the function using this AND operator and assign it to this variable myfunc. Myfunc is a function pointer, and after this assignment, it points to the add1 function, and later we can call myfunc with 10 and 20, which will give us 30. We can actually try this code using an online C runtime environment. For example, let's try using this one. And let's copy over the code. And we run it. And you can see that it produces 30 as expected. The good thing about function pointer in C is that it's pretty flexible, and the syntax is pretty concise, but it's not quite type safe, meaning that we can actually assign a function with a different signature to myfunc. For example, in our example, we also have another function called add2, which doesn't take integer parameters and doesn't return anything. However, we can still assign add2 to this function pointer. If we run it, it does run. We did get a warning here, but it doesn't prevent us from actually running the code. And of course, because this method doesn't have the right signature, so whatever produces by this program is just meaningless. Before we move forward, let's quickly clarify the difference between pointer and reference. Broadly speaking, they are the same thing. The difference is that in C and C++, a pointer is literally a memory address, meaning that you can add or subtract a value from a pointer to get another memory address. This is known as pointer arithmetic, and it is a very well-known security risk. So later languages introduce reference, which is like a pointer but cannot be manipulated to point to some other memory address. Okay, so that's for C. How about Java? How does Java do event handling, for example, without using function reference? Well, let's look at this example, which is actually from the official Java tutorial. In this example, we create a button, and when the button is clicked, it will call this method. But because there's no function reference in Java, we have to create a class for this method. By the way, in case you forgot, the difference between a function and a method is that a function can exist by itself, while a method has to be associated with a class or object. In other words, we can kind of think a method as a special type of function. Anyway, not only we have to create a class for the method, we have to declare that the class implement the action listener interface. And then we have to create an object and then pass the object to the button. Notice that conceptually, a click event handler is really just a function. However, in Java, instead of creating a function, we have to create an interface, create a class, create a method in the class that implement the interface, then create an object of the class so we can use the method. It's type safe for sure, but as you can see, it's really rather tedious. So how does C# do it? Well, C# has two language features related to this: anonymous function and delegate. Anonymous function makes it easy to create functions, and delegate makes sure that functions and methods can be used in a type-safe way. We'll start with delegate, which you can think of as class for functions. An instance of a delegate is an object that represents a function or method, and sometimes it can even represent more than one function or method, known as multicast, which we'll see in a moment. This is the basic syntax of how to use delegate in C#. First, we declare a delegate, which represents functions with certain parameters and return type. In this case, the binary of delegate represents all functions that takes two int parameters and return an int value. To create a delegate object, we call new delegate name, like creating a new object, and then pass the name of a method or function to it. In this case, it's a static method inside the class program. After we have the delegate object, we can then use it to invoke the method like this. Now let's quickly see how it works. Let me copy over this one, and this will declare the delegate, and then let's create a method. We'll say public static int add 1, we'll add another method later on. So this one will be 1, and doesn't really matter parameter name, and we'll say console write line. This is add 1, and we'll return a plus b. And now we'll create a delegate object, and this delegate object will say binary op, and then the parameter name, variable name doesn't really matter. We'll call it Bob, binary op, and we'll say new binary op, and then we'll give it the name of the method. Notice that it's a static method, so the way to refer to it is class name dot method name, and then we can use the delegate object to invoke the method, and let's say we give it 20, and if we run it, oh, haven't changed the project yet. It's still the dictionary one, and this one, yes. Run it, and it said this is add 1 and then 30, which is what we expect. We are now using a delegate object to invoke this add 1 method. So at this point, you may be wondering what's the big deal about delegates. In our example, we could just call the add 1 method directly instead of using a delegate. Well, in this simple example, yes, we don't really need delegate. But delegate really is a game changer for the language because now we can treat functions and methods as objects. This means we can now use functions and methods as variables, properties, arguments, return values, and so on. So it really is a pretty big deal. For example, again, going back to the event handler example, now we can simply declare this click event handler as a delegate and then assign a function to it. There are a few more things we need to know about delegate. Type safety, something called method group conversion, multicast, and two generic delegates that simplify delegate usage. Type safety is the easiest to understand. For example, as we can see in this example, delegate defines the parameter list and the return type of the possible functions or methods. And if we try to pass a method with the wrong parameter or return type, for example, if instead of int we say double, let's say for example double here, then we immediately get a compilation error saying that it has a wrong return type for this delegate object. So what about method group conversion? Method group conversion sounds like something complicated, but it's actually quite simple. It basically allows us to use a method name in place of a delegate object. For example, in our example, instead of creating a delegate object by calling new constructor and then the method name, we can just put the method name directly here. So in this case, it will be something like this. Instead of calling the new constructor thing, we can just put the method name here, and it will still run the same. Note that this applies to any place where a delegate object is needed. For example, suppose we have a button click handler which is declared as a delegate. We can simply assign a method name to it, and the compiler will automatically turn the method name into a delegate object, just like what happens here. Delegate multicast allows a delegate object to reference multiple functions and methods and invoke them together. This is useful because sometimes we want to register multiple event handlers to handle the same event. To make a delegate reference multiple methods, we use the overloaded plus equal operator. Let's see an example. Here we have a static method called add1. Let's create another one. We'll call this one add2. And just to make things more interesting, we'll make this an instance method. And because this one is an instance method, it means that if we try to refer to this one, we have to use to create an object first. So we'll do something like this. We'll say Bob plus this, and instead of saying program.add1, we'll say new program. This will create a program object, and we'll say we'll use add2 in this program object. Again, notice the difference between static method and an instance method. So now Bob is associated with two methods, and in C# terminology, it's now a multicast delegate object. So what happens if we call Bob 10 with 10 and 20 and then try to output the results? Let's see. So notice that it produces add1 and add2, and that means both add method were invoked, and then it produced a returned a single value. Actually, let's change this one a little bit. So let's change this to a -2, and sorry, a -b. And if we run this again, we can see that it produces, this is add1, this is add2, meaning that both methods were invoked indeed. However, the value returned by Bob is the value returned by the second method, because obviously it cannot return multiple values. It returns the values of the latest invocation, which is the second one. So this is how multicast works. The third thing about the fourth thing actually, one more thing about C# delegates is that the C# library provides two generic delegates. Each takes up to 16 arguments, and because they are generics, the parameter types and return type can be customized, meaning that in most cases, instead of creating our own delegate, we can simply use one of these two, depending on whether the function or method returns a value or not. If it returns a value, we use the func generic delegate, otherwise we use action. Func implies that it's like a mathematical function that returns a value. Action means it just does something without returning a value. If we look at the documentation, it looks like this. So the first one is when a function has no parameter but returns a value, the second one is the function has one parameter, returns a value. The next one is two parameters, three parameters, and so on and so forth. And if we look at the action one, it's quite similar, except that notice that there's no return type or result type. It's simply method that takes one parameter, two parameters, no parameter, and so on, up to 16 parameters, but returns no value. Now, if you look at this, it looks kind of complicated, but it actually is pretty simple. All it means is that, for example, instead of us creating a delegate like binary op that takes two integer parameters and return an integer value, we can simply use func. And the func will take three type parameters, like here, like this one, this one. And the first two will be the type of the parameters, and the last one will be the type of the return value. So this one basically means that this will represent all the functions and methods that take two int parameters and return an int value, exactly the same as this one. So instead of creating our own, we can just use this. And for example, we can simply say int int bob2 and its program add one. And so this one, is basically the same thing as this one, and it has up to 16 arguments, meaning that for anything with 16 arguments or less, we don't need to create our own delegate type. We can just use either func or action, depending on whether we want something to return a value or not. Okay, so now we have delegates, which turn functions and methods into objects, and that's great. But we still need a way to create functions, because otherwise it will be like in Java, where we have to create a class and then a method. In C Sharp, there are two ways to create so-called anonymous functions. Anonymous functions are basically functions without names. You may be wondering how we can call a function without a name. Well, it's easy. We just assign the anonymous function to a delegate variable and call it through the delegate variable. Like this one. This syntax is called anonymous method, and this is a way to create anonymous functions in earlier versions of C#. Later, C# introduced another syntax to create anonymous functions called Lambda expression. So this syntax is rarely used nowadays. But just in case you encounter some existing code using this syntax, this is what it looks like. Instead of a function name, it says delegate here. Like I said earlier, it's immediately assigned to some delegate variable, so it can be later invoked through that delegate variable. Two more things worth noting here. First, it can access variables outside the method, and secondly, the whole thing, and that means up to here, this whole thing is considered an expression, so there has to be a semicolon here to end the assignment statement. The newer syntax for anonymous functions is called Lambda expression. I think the expression part means the whole thing is considered expression, like the anonymous method. But inside the function, we can actually have multiple statements, which is different from the expression body member we talked about earlier. If we compare the syntax with anonymous method, we can see that they are basically the same thing. So this part compared to this part, they're basically the same, except that instead of using the keyword delegate, we use a lambda or arrow operator. Lambda expression has some syntactic variations depending on whether it has one statement or only has one parameter. For example, if it only has one statement, we can omit the braces, and if it has only one return statement, we can also omit the return keyword. We can drop the parameter type because the compiler can infer the type from the delegate type, and we can drop the parentheses if there's only one parameter. If you know JavaScript, you probably are already familiar with syntax like this. The difference is mainly that C# is a statically typed language, and delegates make sure that the types are correct. Delegates and anonymous functions are widely used in C#. Let's do an example with the FindAll method in the list class. Hopefully, this will get you more comfortable writing anonymous functions as well as reading C# documentations. So the example we'll do is this. We'll have a list of names. And let's say we have a name of John Doe and Jen Doe and Tom Smith. And I think I need to import. Yeah, we are going to import the collections.generic namespace. And having this list of names, we want to find out all the names whose last name is Doe. If we look at the documentation, we can see that there's a FindAll method in the list class, and it says retrieve all the elements that match the condition defined by the specified predicates. So if we look at the signature of the method, it returns a list of type T, and this T, of course, is the same of the current list type. So in our case, it will be string, and this presumably should be the list of names that has a last name Doe. But if you look at the parameter, it says predicate, which is a generic itself, which has a type T, and then match. So what exactly is predicate of type T? So let's look at that. And here we see that this predicate type T thing is in fact a delegate. And this delegate will take a T type T object of type T and return a Boolean. And what is the type for this one? Well, look at here. This type has to be the same as this type. That means in our case, this should be an integer. Sorry, should be a string. Okay, so knowing this is a delegate, we can do something like this. We can say predicate string, and this is going to be delegate object or delegate variable, and let's call it check. Remember, this type needs to match this type. And what do we assign to check? Well, the thing to assign to a delegate object or delegate variable should be a function. And here, instead of creating a method in a class, we can create an anonymous function. And what should this anonymous function look like? Well, if we look at this delegate, it says the function should take an object of type t and return a boolean. Okay, so that means it should take a string and returns a boolean. And boolean, of course, is true or false, whether element meeting certain condition. So we'll say if s ends with space though, that means this string ends with space though. That means the name has a last name though. Okay, so this is the function. Now we are assigning it to this predicate variable, or in other words, a delegate variable, and then we can call the FindAll method by passing that variable to the method as the argument. So the result will be names.findAll, and we pass check to it. And let's use a for each to print out the results and see if it's indeed what we are expecting. So if we run this, we get John Doe and Jane Doe, which is indeed what we want. And in fact, if we change this to Smith, we'll be only getting Tom's. So it indeed works. Now we can simplify this code a little bit more. Notice that this is an anonymous function which we assign to this delegate variable. Now, anonymous function has another name, and it's often also called a function literal. So what's a function literal? Well, remember what is a regular literal, right? So a literal is basically a value of a certain type. For example, 10 would be an int literal. Now, knowing that tells us that if we assign a value to a variable, then pass that variable to the argument, then we can get rid of this middleman and simply pass that value directly here. And if we run it, it works perfectly fine. And that's why anonymous function is also called a function literal, because we can use it as if it's a value, which is indeed counts as a value, and pass it to where a delegate object is needed. Okay, so the example is simple, but you'll see this type of syntax quite often, so get familiar with it or be comfortable with it. Actually, we can simplify this even more by get rid of the parentheses and type As we said earlier here, the type can be omitted because it can be derived from the inferred from the delegate type. So we can further simplify the code like this, and it still runs correctly. Okay, so that's about it for delegates and anonymous functions, and they are covered in chapter 12 of the Pro C# 9 book. Please check it out. This is the end of this video. Thanks, and see you in the next one.